It's raining outside and we are going to discuss a new topic which is called free body diagram. Now let us understand what this free body diagram actually is. Now this free body diagram is used to study a system consisting of more than one body. Now what we do in here is, although the system consists of more than one body, but what we do is we look at each body individually and we look at all of the forces acting on the bodies separately. So therefore, a diagram showing the forces on an individual body is what is called a free body diagram. Take for example a system of two bodies A and B, body A having mass m1 and body B having mass m2, where m1 of course is greater than m2 as you can see in the picture. Now these two bodies A and B are connected by a massless and inextensible string which passes through a very smooth, that is a frictionless pulley. Now since the mass m1 of body A is greater than the mass m2 of body B, therefore the body A is obviously going to pull this body B. That is, the body A will move with a certain acceleration A in the downward direction, and body B is going to be pulled up with the same acceleration A. Now since body A is being pulled in the downward direction and body B is being pulled in the upward direction, therefore the string is going to be stretched or tensed. That is, a force of tension acts on it. Moreover, as the pulley is frictionless, therefore the same force of tension acts on both sides of the string. So here is the free body diagram for the system, wherein we have considered the two bodies separately and we are also considering the individual forces acting on the two bodies. Now considering the motion of body A, it is being accelerated in the downward direction, which means there has to be a net force acting in the downward direction, which thereby tells us that this m1g, that is the weight of body A, has to be greater than the force of tension. So m1g minus t is the net force acting in the downward direction, and it is this net force which is producing acceleration of the body. So m1g minus t has to be equal to the mass of the body multiplied by the acceleration produced in it according to Newton's second law of motion. Likewise, considering the movement of body B, since it is moving with an acceleration A in the upward direction now, the tension acting on it should be greater than its weight. So therefore the net force on body B is acting in the upward direction. Thereby we have T minus m2g, the net force acting in the upward direction, is equal to m2 into A. Then after its simple mathematics, what we do is we add equations 1 and 2, because of which what we get is m1g minus m2g is equal to m1a plus m2a. You all can check the mathematics. Thereby we get the acceleration produced is equal to A, which is equal to m1 minus m2 divided by m1 plus m2 into g. So this is the value of the acceleration with which body A moves in the downward direction and body B gets pulled in the upward direction. Therefore, substituting this value of A in equation 1, you of course can substitute in equation 2 also. We get m1g minus t is equal to m1 into A. Now since the value of A is this, so we have substituted the value. Then after you can check the mathematics yourself. Finally we get the value of the tension T is equal to 2 m1 m2 divided by m1 plus m2 into the acceleration due to gravity. Therefore, by studying the free body diagram, we've got to analyze or study the system on the whole. Another scenario is again that of two bodies A and B having masses m1 and m2 respectively, where m1 is greater than m2. Here also the two bodies are connected by a string which passes again through a smooth frictionless pulley. Now since the mass of body A is greater than that of body B, therefore body A is going to move with a certain acceleration in the downward direction, because of which the string is going to get tensed and the tension produced is T. Now since we've already considered the pulley to be frictionless, therefore the body B is going to be pulled because of the tension T that is generated on this side of the wire. So here is the free body diagram for the case, and we can see that there are three forces acting on body B: M to G, its weight, and R, the normal reaction. Now since the normal reaction and weight are equal and opposite to each other, therefore they cancel each other out. And thereby the only unbalanced force that acts on body B is capital T, that is the force of tension. And it is this force of tension which produces an acceleration A in case of body B. And we have two forces, M1G, the weight of body A acting in the vertically downward direction, and the force of tension T acting in the upward direction. Now since the overall motion of body A is in the downward direction, therefore M1G is greater than T. So to say, a net force M1G minus T acts on body A, which produces an acceleration small a acting in the downward direction. Therefore for body A, the net force acting on it, which is M1G minus T, is equal to its mass M1 times the acceleration produced in it, according to Newton's second law of motion. Likewise, for body B, the only unbalanced force acting on it is the force of tension, and it is this force of tension which is producing the acceleration A, like I've already mentioned. Therefore, T is equal to its mass M2 into the acceleration produced in it. You all can now solve these two equations. You can start by substituting the value of T from equation 2 in equation 1 and get the value of the force of tension and the acceleration acting. And you will see that the acceleration A will be equal to M1 upon M1 plus M2 into G, and the force of tension T acting in the string is M1 M2 upon M1 plus M2 into G. So we've looked at two basic kind of systems where we will apply free body diagrams. Now what you might get is, you might get numericals based on similar kind of systems, wherein of course you have to consider the free body diagram, and you might be given the values of masses and of course the acceleration due to gravity, and you'll be asked to find the value of the tension and the value of the acceleration for the different systems. So what you need to learn to do is, you need to learn to look at plus understand the free body diagram for the various systems. And of course then get the equations for each of the bodies involved and thereby solve those very equations.